Welcome to Top Stack. Thank you for stopping by and watching one of our tutorial videos. My name is Michael.
And my name is Fria. May you enjoy learning.
For Discrete Math tutorial video number 69, we are to discuss everything relevant about GCD and LCM. GCD. Just so you know, GCD stands for two meanings: greatest common denominator and greatest common divisor. While some books may state that the greatest common divisor is also known as the greatest common factor, highest common factor, greatest common measure, or highest common divisor. Anyhow, same point. It comes down to this question: what is GCD? In mathematics, the greatest common divisor of two or more integers, which are not all zero, is the largest positive integer that divides each of the integers. For example, the GCD of 8 and 12 is 4. Before moving forward, don't mistaken GCD as LCM. GCD is usually mistaken for another mathematical term. Again, don't mistaken GCD as LCM. The least common multiple, or LCM, of two numbers is the smallest number, excluding 0, that is a multiple of two or more numbers. The greatest common factor, or GCF, or GCD, is the greatest factor that is common to two or more numbers. How do we find out and get the GCD for two integers? Well, there are four methods. The easiest one would be by listing all the divisor of the given numbers. As an example for method 1, let's set it to be 45 and 54. List all the divisors, or any number that divides the number which would not come up to any remainder. As for 45, we got 1, 3, 5, 9, 15, and 45. For 54, 1, 2, 3, 6, 9, 18, 27, and 54. The greatest common divisor for both numbers is 9. Second method is called prime factorization method. Using this method, first find the prime factorization of each number. The GCD of all numbers is the product of the common prime factors. As an example for method 2, let's set the numbers to be 24 and 60. Continue on getting their prime factors. For 24, its prime factors are 2, 2, 2, and 3. For 60, its prime factors are 2, 2, 3, and 5. The common prime factors are 2, 2, and 3. The greatest common divisor of 24 and 60 is the product of these common prime factors. As for the given, 2 times 2 times 3 equals 12. Third method is division by primes. As what the method suggests, divide the numbers by their common prime factor. You just have to do it multiple times. Easy as that. Stop when you no longer can come up with a common prime factor. As an example for method 3, let's set the numbers to be 24 and 60. First, divide all the numbers by the smallest prime factor that can divide both of the numbers. The smallest prime number that divides 24 or 60 that I could be thinking of is 2. Continue the steps until we can find any prime number that can divide all the number on the right side. The GCD is 2 times 2 times 3 times 1, which is equal to 12. The fourth and final known method is called the Euclidean algorithm. In accordance to its method name, the algorithm was as proposed by one of the ancient mathematicians, Euclid. This algorithm finds GCD by performing repeated division. Starting from the two numbers we want to find the GCD of until we get a remainder of 0. As an example for method 4, let's set the numbers to be 24 and 60. Divide the larger number by the smaller number. Next is we must divide the smaller number from the previous equation by the remainder from the last division. Repeat until you get a remainder of 0. The GCD is the smaller number from the previous equation before you came up with the remainder of 0, which is 12. Therefore, the GCD is 12. The latter part of this tutorial video is regarding least common multiple.
Again, what is LCM? The least common multiple, or LCM, of two numbers is the smallest number, excluding 0, that is a multiple of two or more numbers. Digging into the concept, there are three known methods on getting the LCM. The first method is called prime factorization method. Using this method, first find the prime factorization of each number. In contrary with GCD, the factors are written in index form, and the LCM is the product of each prime factors with the greatest power. For method 1, let's set the numbers to be 24 and 60. Write the prime numbers in index form. For 24, we have 2 times 2 times 2 times 3, or 2 cubed times 3. For 60, we have 2 times 2 times 3 times 5, or 2 squared times 3 times 5. The least common multiple is the product of each prime factor with the greatest power. So, for the above example, the LCM is 2 cubed times 3 times 5 is 120. For the second method, it is called division by primes. As what the method suggests, divide the numbers by their common prime factor. You just have to do it multiple times. Easy as that. Stop when you no longer come up with the common prime factors. As an example for method 2, let's set the numbers to be 24 and 60 again. First, divide all the numbers by the smallest prime factor that can divide both of the numbers. The smallest prime that divides 24 or 60 is 2. Continue the steps until we have all the prime numbers on the right side and at the bottom. The LCM is 2 times 2 times 3 times 2 times 5, which is equal to 120. For the third and last method, we call it formula method. This method is very effective once you're able to determine the GCD by any means of both of the numbers. It simply suggests to multiply both of the numbers and divide their product to the GCD. As an example for method 3, let's set the numbers to be 24 and 60. Write down the figures in this format. Again, as the method suggests, multiply the given numbers and divide it by its GCD. Once you're able to get the GCD of both numbers, perform the method. The LCM is 120.